morning, afternoon, or evening, wherever you are watching from today, and welcome to the live broadcast of the Vega C rocket with the Biomass payload launching today at 9:15 a.m. UTC from French Guyana Space Center, and we're looking at live views from the capsule here. It is pretty laggy here, not sure what is going on, but we can see live views from the pad as we are just 21 minutes away. Everything is looking good for the launch so far. The broadcast from the YouTube channel has already started, so that is very good news. So great to see the views from the launch pad here as we're getting closer and closer to that liftoff at 9:15 a.m. UTC. So that's gonna be pretty cool to watch later on. It seems that the broadcast has already started on their YouTube channel, like I just said, so we can go over there and look if it's gonna let me. Probably gonna use this footage for a little bit, but we can just check over here what is going on there. Yep, live coverage will begin at 55, so 1 minute away until they will start their coverage. We're not gonna pay much attention to their coverage here. Might just copy some words here and there, but that's all. So yeah, once again, everything looking good for that launch today. And about Vega C itself, I don't know if many know this. If you do, Vega C is actually solid, or the first stage actually. Wait, let me check. Yep, so Vega C, the rocket itself, has three stages powered by solid propellant, and the fourth stage that uses liquid propellant. So yeah, that is very interesting. So 3 stages of the Vega C rocket are solid propellant, so there is no freehand operations for that. But the fourth is. So this will be the first Vega C launch of 2025, which is a very good record already for them, and the second mission of 2025. So let's hope Vega C launches successfully today, as it has a pretty good success rate. There was one failure from Vega C. I think that was the previous, no, that wasn't the previous launch. That was back all the way back in 2022 for the second Vega C launch, carrying the Pleiades Neo 5 and 6 satellites, and that did not really go as planned, but luckily it is hopefully gonna go as planned today, as everything is looking good for that launch. So let's actually listen into their coverage. I said we're not, but let's just do it. Why not?
To penetrate the canopy even through clouds.
Our satellite is in there, on the top of the Vega C rocket, ready to start its journey into space.
For this YouTube Live, we will be here in the Jupiter Mission Control Center.
Right by your side to guide you through the operations. I'm Samuel Rogers.
I'm Katie Haswell, and welcome to flight number VV26.
Yep, flight VV26.
A very big.
So yeah, that was their coverage on that, or their announcement on that. So yeah, we got about 17 minutes and 30 seconds until the launch here. So we got quite a bit of time left until that planned liftoff. Actually, take a look at the French Guyana Mission Control Center here, as we can see. And those are the commentators for Road to Space, or the Arena Space coverage. So you can just watch that there if you like. So we got a lot to cover here. The Biomass payload, a very important payload. They always cover the payload as best as they can. So let's go to the control room here where the operations are in work. So yeah, and here's an interview there, so we're not gonna listen to that. So we got a bit left, and about the Biomass payload here, I can give you lots of information on that. If you have a minute though, let me just... Alright. I think we are good. So yeah, about the Biomass payload, it has a lot of information, so I'm just gonna make it short. Let me just try to read it. So it's an Earth Explorer mission, very interesting. The innovative satellite aims to map and monitor one of Earth's most precious resources. The satellite will be designed to provide for the first time from space P-band radar measurements that are optimized to determine the amount of biomass and carbon stored in the world's forest with greater accuracy than ever before. This information, which is poorly known in the tropics, is essential to our understanding of the role of forest in Earth's carbon cycle and in climate change. So, yeah, this is very important for Earth itself. So this is basically an Earth observation mission. Earth Explorer mission, which is very important for the Earth and space community here. So the space flight community. So yeah, and it's going to be better than ever before, which is of course going to be very good news if the launch goes as planned, because this is a very important mission. They expect it to go as planned here. And the sun is slowly rising here in French Guiana. Here are the steps for the launch. Starting from launch and then stage separation 2 minutes and 25 seconds. And then the second stage ignites, also solid propellant. And then a bit later, it will also shut down at 4 minutes and 32 seconds. It will separate. And then the third stage will ignite, which is also solid propellant, and then the fairing will separate, and there's actually a fourth stage as well, and that will be liquid propellant, I assume. Yep, that will be liquid propellant at 8 minutes and 23 seconds. Once again, we'll cover, or I did not say this before, we will cover the entire mission from beginning to the end, as long as they will cover the launch. So all the way till T plus 53 minutes, and we'll cut off, we'll go again, and then at 57 minutes the Biomass payload will separate. So yeah, we'll cover that entire mission program from start to finish. And yeah, let's hope for a great flight from French Guiana. Let's brighten the colors a bit. Oh, there will actually be a third ignition later on. So the mission will continue after it is launched. But we're not going to cover that. We're going to cover until the payload has deployed, and then we'll end the coverage. So that is gonna be our limit. Taking a look at the beautiful mission control. And as you can see, the sun is slowly rising as it gets brighter and brighter in the sky. here information video about biomass, if I'm saying it right.
For thousands of years, forests have acted as the lungs of our planet, absorbing carbon dioxide, releasing oxygen, and sheltering an incredible variety of life. However, deforestation, climate change, and human activity are changing these essential ecosystems at an alarming rate. So how can we accurately gauge the extent of organic matter stored in our forests? The answer lies above us, in the silent, watchful gaze of a satellite. Introducing Biomass, a revolutionary Earth observation mission set to change the way we see and study the world's forests. Biomass is part of the European Space Agency's Earth Explorers program, pioneering scientific missions designed to deepen our understanding of Earth's complex systems. Today, from Europe's spaceport in Kourou, Biomass will embark on its journey aboard Vega C. Weighing 1,250 kilos, this cutting-edge satellite will be placed in a sun-synchronous orbit, 670 kilometers above Earth. Its mission? To deliver the most accurate map of biomass distribution in Earth's forests. Equipped with a fully polarimetric P-band radar and a massive 12-meter diameter reflector, Biomass is the first satellite ever to carry a radar instrument capable of penetrating dense forest canopies to collect information on tree trunks and branches, where the majority of carbon is stored. Forests are among our strongest allies in our efforts to mitigate climate change. They store vast amounts of carbon, but the exact quantities remain uncertain. Rising temperatures, increasing CO2 levels, and expanding human activities are reshaping forests in ways we still don't fully understand. Biomass will provide the first ever global estimates of forest biomass and height. Over its 5-year mission, Biomass will systematically scan the entire globe every 9 months, delivering crucial data on forest structure, biomass distribution, and above-ground carbon storage. This is the missing piece scientists and foresters have long sought to improve climate projections. Governments, conservationists, and researchers will have access to reliable and consistent forest data, enabling them to make informed decisions that shape the future of our planet. By unveiling the unseen, Biomass serves as a storyteller for our forests, a beacon of knowledge in the pursuit of a more sustainable future. Because to protect our environment, we must first understand it.
And that was an awesome video from French Guiana displaying what biomass will do in the coming years, months, and all that stuff. So yeah, this will be a very important mission for Earth's climate, so they can figure out what is what. So we're about 9 minutes 25 seconds until the launch here of the Vega C rocket with Biomass on board. And it looks like everything is going as planned. We're just looking at views from mission control. And yeah. So once again, launch will be at 9:15 a.m. UTC time, which is 9 minutes from now. And that is in local time in French Guiana, 6:15 a.m. So yeah, it will launch 6:15 a.m. in French Guiana. That's what time it will be. At 9:15 a.m. in UTC time. So yeah, we got about 8 minutes 30 seconds until the launch. Later today as well, we'll have the second attempt for Firefly's message in a booster carrying LM400 demo satellites, I think, for Lockheed Martin, which is going to be a very important step for Lockheed Martin and the Firefly Aerospace. So though we're taking a look at the tracking sites in Germany. It's not far from me. I live in the Netherlands, so I think it's not even that far. That's interesting.
Power.
Just listening to music control now.
Speak on go. Timeline. Timeline go. Project rep.
Project rep, go.
PST lead. Software coordinator. Software go. Software support.
Software support, go.
Flight dynamics.
Flight dynamics, go.
OM.
OM, go.
S-track.
S-track, go.
Scheduling.
Scheduling, go.
Excellent. This completes the biomass roll call.
So they are go for launch. We are go for launch. The boards are.
Alright, everything is go for launch, as you just heard. The board all is green. Very good news. Just under 7 minutes away from the launch here of the Biomass satellite. Once again, about the Vega C rocket itself, the rocket has 4 stages in total. 3 stages are solid propellant, and the 1 stage is liquid propellant. So that's just an interesting fact there for you. And here are the mission control. Well, I don't know where this is exactly. I don't know if it's at Vega or Germany anymore. But yeah, that it is what it is. So we got just about 6 minutes left. Let's just listen in to the commentators from Arianespace for a few minutes, and we'll be back.
Are actually running the operations, and the one behind are checking that the actual parameters are in line with the expectations, and checking if any deviation, then analyzing the situation.
Laser focus at this point as we get closer and closer now to the launch. Vega C standing tall on its pad. Now everyone also has their eyes on the status panels. We saw them earlier here in the Mission Control Center, the green panels. There they are on the left-hand side of the screen there.
Yeah.
All green at the moment, good sign.
It's a bit like the traffic lights. If it's green, we can go ahead. If it's red, of course, we'd better stop and analyze. And each of these panels actually corresponds to a person, a team operating or monitoring that system. Could be, for instance, one for the rocket, of course, checking for instance, the tank's pressure or temperatures on board, the status of the onboard computer. Of course, we check also the communication links, the weather status, as we mentioned before, but for sure also the passenger Biomass, which has its own status panel, which is on the screen. And of course, if something goes wrong, if there is any parameter that deviates from should be the nominal value, then we notify the range operation manager, and we can hold the countdown time needed to analyze the situation and then assess what the next step should be.
Coming up now to the beginning of what we call the automatic sequence or the synchronized sequence. That's the last 4 minutes. Coming up, we'll just briefly, Samuel, what is that?
À tous de DDO. Attention pour la séquence finale lanceur.
Range Operations Manager Jean-Frédéric Alassa today getting ready to announce it.
Top H0 4 minutes.
So what is the synchronized sequence?
During this sequence, in fact, the rocket is becoming progressively autonomous. So currently the computer are managing an impressive sequence of complex operations, each of them timed to the millisecond to get progressively the full autonomy to the launcher.
Now, the job of preparing the rocket and the spacecraft here at the spaceport started a couple of months ago. We call this process the launch campaign, and the teams have been working extremely hard during that time to get everything ready for today. Our cameras were there. Samuel, what's been happening?
So first, most of the parts of the Vega C launcher arrived actually by sea, as you can see, at the port of Kourou, and were then transported by road to the Space Center. The rocket is assembled step by step from several parts, which we call stages. Here you see the first stage, P120 booster, transported to the launch pad, and then we have the second stage here, which was hoisted and then assembled on the top of the first stage. The third stage, the Zefiro 9, is also lifted into the gantry and integrated on top of the two first stages. Then it was the upper stage, the Avon Plus, which arrived in its dedicated container. You can see it there. It's hoisted, unloaded, and then integrated onto the first stages. As for the satellite, Biomass arrived in French Guiana on the 7th of March, also by boat. A number of operations were carried out in autonomy for Biomass. Then it was filled with propellants, and you will see the special suits that we use for this operation. Here you see it on the movie. Then it was integrated on what we call the adapter, which is the structure which make the link between the satellite and the launcher. This is the black cone you see on the screen. And then it was enveloped in the fairing, this huge part you see, and what we call the upper composite was then transferred into the launch pad. It was hoisted on the very top of the launcher and then integrated on the upper stage. Finally, we have, as we said, removed the gantry and we have the launcher ready for liftoff.
Indeed, and here we are, 1 minute and 31 seconds now to launch, hoping for a very beautiful dawn launch. Getting close, quite tense at this moment before launch, isn't it?
Yeah, we can clearly feel the intensity, the concentration, all the teams are focused on their task.
À tous de DDO. Attention pour moins 1 minute. Top H0 moins 1 minute.
All right, we're less than a minute away from the launch. So here we go. Thirty seconds.
À tous de DDO. Attention pour le décompte final.
Alright, we're just gonna do the countdown here. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of Vega C for Biomass. It's already through the clouds.
Pilotage calme. Trajectoire nominale. Acquisition Saint-Jean. Trajectoire toujours nominale.
Sunrise over the Amazon rainforest, and Biomass has started its journey, blazing a trail on board the Vega C rocket on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying over the...
Amazing pictures, and yeah, we can feel the walls
shaking here at the Jupiter Mission Control Center. He's telling us that everything is going well.
Yeah, so far it's perfect. We are lucky to see it so long. It's given the cloud we had at the beginning.
Beautiful launch.
Getting some great views here from our cameras. Burning the P120 first stage here, which is getting us away from the gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting.
Yeah, control of the thrust, the orientation of the thrust as well. So it's nominal means everything's fine.
Good. Coming up
Début côte poussée.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic
Actually,
views.
we could see it from the cameras. It could be nice. Yeah, should occur in a few seconds now.
Indeed, this is the scheduled moment for the
And you can
separation.
see it on the,
Séparation P120.
and it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120
nominale. La
first
trajectoire est nominale.
stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for Zephyro. It's an Italian name for a type of wind, because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Guyana Space Center.
So yeah, good views of the launch there. Everything is going as expected. I'm just gonna be back shortly. Enjoy Ariane Space Commentary for a few moments.
The rocket is normal.
It's perfectly as planned. Yeah.
And of course, the fairing, which is where our satellite is encapsulated at this point, Samuel, is the nose cone, if you like. We saw it before
La
the launch.
trajectoire est nominale. Le pilotage est calme.
And
It has a multiple.
it's got a number of jobs, hasn't it?
Yeah, exactly. Yeah. It basically protects biomass from a number of environments. First, of course, the Guyana environment, the rain and the dust, everything. But also at liftoff, we have, when we
Début côte poussée.
fire the booster, there is quite a high acoustic vibration environment. Then the fairing is used to damp it, and as well to
Trajectoire nominale. Pilotage calme.
as we go through the atmosphere, it helps reducing the heat load generated by the friction with the atmosphere or the vibration. So it's quite a clever piece of hardware. Yeah.
Very important. You can see it at the front of the rocket there, the sort of bulbous section. Right, we have now the scheduled moment to separate the Z40 to jettison that.
Séparation Z40.
That's
So we
been...
just confirmation that the Zephyro 40 stage has been separated.
And
Allumage Z9.
And
we've switched on the...
Alright, I'm back now. We can see everything going as expected here. Looks like it. Go a bit off course though. Looks like everything is going as expected now. Barely hanging by an inch. Okay, trajectory is nominal. Okay. Trajectory looking good. T plus 6 minutes. Just trying to do something here. Let me just cook real quick. Just taking a look at the course it's flying in. Taking a look at the course here, it looks okay. Of course it's solid propellant, it's not like 2000% accurate here. And there we have it. The separation of the third stage and the fourth stage will now ignite. Just having a little bit. Will take a little bit before we have that second ignition, or the fourth stage ignition, sorry. That should happen in a few seconds from now. So it's now orienting for that burn. And there it is. It is burning now. First stage ignition. Fourth stage ignition. Everything is going as expected here. Let's listen to the aerospace broadcast again.
And tested by the European aerospace giant Airbus Defence and Space, and all of that's been done in the UK.
Yeah, and they are what we call prime contractor. So it's like they are conductor of an orchestra.
Propulsion nominale de la VOM, pilotage calme.
It means they manage a group of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware for Biomass. And in particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
In fact, I was lucky enough to see it because I was filming there a little while back, and it was really exciting to see Biomass in the clean rooms taking shape. Big shout out actually to my fellow compatriots in the UK, Airbus in Stevenage. So let's just check where we are in the flight. We are climbing.
Close to 300 kilometer altitude. And 3,000 kilometers.
La trajectoire de la VOM est nominale.
So trajectory is perfectly on the target. We are running gently the propulsion of the Avon Plus, consuming propellants.
And we're coming closer now to picking up the signal at the Gatineau tracking station. You can see it there in Canada, the northeastern coast of Canada.
l'acquisition de la télémesure par la station Gatineau.
He's just confirmed that we've picked up the signal there. It's a bit like a relay race, isn't
Exactly,
it?
yeah.
Handing the baton from one tracking station to another.
Yeah, we want to be sure to have contact with the launcher during this phase while propulsion is active to receive the parameters.
Pression nominale des réservoirs, le pilotage est calme, la trajectoire est nominale.
Everything's going normally. So the rockets...
All right, so that was just some calls there and some talking from the commentators here. So that 4-stage burn will last a very long time here, I guess, because it needs to be on a precise orbit. Once again, later today at let me just check. In 4 hours and 8 minutes will be the Alpha Alpha rocket launch with message in the booster. That Firefly will be launching Firefly's Alpha rocket with message in the booster with Lockheed Martin 400 demo satellites. And these will be the first of up to 25 launches of low Earth orbit technology demonstration satellites to be built and operated by Lockheed Martin. So that is for the next launch, which will happen in 4 hours and 8 minutes from now. So we still got a little bit. The boys will actually be there as well. So it's going to be very cool to see that occur. So yeah, we got a little bit until that is happening. But that is not now. Like I said, still in like a little bit. Let's actually listen back in.
There are people from different teams, such as propulsion, structure, control,
Le lanceur est mis sur orbite.
and they are available and ready to jump if needed as a support team. So it's very useful.
And indeed, as you say, they are the manufacturers of the rockets, so it's very useful to have them there and to have as many people on the job as possible. Indeed, as I was saying, one of the features of the upper stage is that it can switch its engine on and off, and that's actually very important. Why is that?
Yeah, it's very key because it's a major asset of this upper stage, because it makes possible to take different passengers, like you say,
L'écart en altitude, la trajectoire est nominale.
like a space bus, to put different passengers to different orbits, but in the same launch. So this is really key. And with this upper stage A1 Plus, we can fire it up to 8 times, and this is much more than the previous 5 on little sister Vega. And so it's very helpful to deliver several satellites on typically 3 different orbits we can reach with Vega
Reste 1 minute de propulsion de l'avant.
on the same
La
mission.
propulsion est nominale, trajectoire nominale.
So it's really a key asset for our customers indeed.
And it means that you can take pretty well any satellite to any orbit, and that's very important, that level of flexibility.
Yeah.
And we're getting ready now, the Avram upper stage is getting ready to switch off its engine. How does it know when to switch it off?
In fact, this is based on its initial position, which we feed the launcher with on the pad, and then it has clever instruments along the flight, computing where it is and how it's oriented, what's its velocity all along the flight. So
Propulsion nominale, pilotage calme.
it knows precisely where it is and when to stop it, and which should occur soon.
We are 329
Fin de la
kilometers
visibilité par la station Bermude.
above our planet. We have now gone out of range of the Bermuda tracking station, and we're being tracked by Gatineau, getting ready to switch the engine off.
Propulsion nominale,
There's
pilotage calme.
that engine that's
For the
now switched off.
Extinction de l'étage avant.
And we have the switch off of the upper stage engine now confirmed, so that's really good. Why now? Why do we
Orbite
switch it off
atteinte
now?
par l'étage avant correct.
So it's just saying that when we stopped the engine, as I was saying, we were exactly on the point we wanted to be. So this is really a good news. And why do we stop it? We stop it because we are climbing to just below 700 kilometers, and we'll do it in 2 steps. So here, this is the first step, and we have reached the
La
target.
pression des réservoirs est nominale.
So we just stop it, and it's all very normal as planned.
Now, today's launch is the
Orientation
result
pour le mode
of
barbecue.
years of collaboration across many, many teams, and we've been talking to some of them. Let's hear from them now.
All right,
chef de mission,
they're now just
Ariane
going to
Espace.
talk about some stuff in the mission, so we're not going to pay much attention to that. So yeah, we're gonna take a little coverage break on our side here. We will be back once they restart for the second engine, or the 4-stage ignition. Sorry, I'm so into Falcon 9 now. So the 4-stage ignition, re-ignition will happen around 40 to 50 minutes after launch. I will just check in a bit. So yeah, we'll be back for that. We don't really have music here, so you're just gonna have to stand by with this sound. So until then, we'll be back. Alright, just coming back. We're just gonna listen to the coverage from Ariana Space now. So yeah, enjoy that.
For that moment we're hoping for a bit later on where we'll pick up the signal, but for now we can enjoy standing here, and I'm here very happy to be joined by Biomass mission scientist Bjorn Roman, who's going to tell us a little bit more about what Biomass is going to do. So thank you, Bjorn, for being here. It's your baby. How are you feeling having seen that spectacular site?
Yeah, spectacular launch, Thomas. It was great to see it from here. We're also joined here by a lot of people from the science team. We've been waiting for this for years, and of course waiting now for the spectacular things that are to come after the launch.
Absolutely, and I saw the emotions on people. It's quite a moment here, and there's still more moments to come. Now, tell us a bit more about this. One of the key goals of Biomass is to study the role that forest biomass plays in the carbon cycle. How is the data from the mission going to help fill in humanity's understanding of this?
Yes, Thomas. A very good question. The main science question of the Biomass mission is really to try to unravel the main unknowns that we have in the global carbon cycle. As people know, most of the actual CO2 emissions that are going up in the atmosphere are coming from the burning of fossil fuels, but the remaining part is coming from land use change, and most of it can be attributed to deforestation. And this is and on the other side, there's of course as well then the actual sinks. About half of it, what we're actually emitting, remains in the atmosphere. About 3/10 is going back into the forests. So this is actually a very good thing. This is actually one of the few things where forests are known for. Is that actually there's a very natural way of capturing carbon, and actually the forests are growing from it. So it's actually a very, very nice thing. The remaining part is going into the ocean, and for the oceans actually it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the Biomass mission will especially look at the tropical forests, and this is exactly the areas where the largest unknown, so we have a gap in our knowledge, and on top of this, there's also the place where we know the largest changes are occurring.
Yeah, exactly. And I mean, when we're looking at those things, I mean, we've had radar missions from ESA before. These are studied in other ways. I mean, what is it about Biomass's radar that makes the technology so unique and so special for this?
Yes, I can tell you about this, Thomas. So as you mentioned, ESA has been flying radar mission before, and the type of mission that they're flying, type of technology, synthetic aperture radar, we're flying this actually already since 1991, ever since the launch of ERS-1. So SAR is not new to us, but what is new to us is especially the frequency that we're flying. We're flying for now with Biomass. We're flying the lowest frequency used for Earth observation for radar imaging ever used by mankind. So this is a really unique, and with this wavelength, we're able to actually penetrate down to actually the forest and down to all types of natural media, which would give us additional new information, complete new information on our planet. And in the forest, we're able we're actually sensitive to the larger structures that we see in the forest. So think about the branches and the stems, and this way we can get, let's say, really new information that we can then later on relate to forest biomass and forest height.
Excellent, amazing. And I mean, I understand these forest ecosystems are incredibly diverse and varied. I mean, Biomass, I think, will allow scientists to differentiate between the different types of forest to measure the biomass. I mean, how's it going to do that?
Yes, this is a very intricate process with a lot of very interesting algorithms that we're going to do. The first thing, of course, we get the data from the satellite, and with this, we hope to be able to estimate biomass, but as well forest height. Together with these two, we hope to be able to constrain our solution space in the end. What we have on top of this with Biomass is that we have a very exciting first operational phase of the mission where we employ tomography, and it's actually the first time where we systematically employ this type of operations during a mission. And with the tomography, which you can compare like with a CT scan when you have to go to hospital. Hopefully you will never have to see this type of device, but it's able, let's say, to slice 3D slices of the human body. And we're doing something similar in the forest. So we get information on the 3D structure, in the forest, so we get a 3D view on what is happening there. And with this, we hope to get as well additional structural information that we can relate to different forest species, different forest biomes.
Wow, really fascinating. And I mean, yes, so Biomass is one of our Earth Explorers. The Earth Explorers all have a topic, and Biomass is focused very much on forests. But are there other areas you expect this mission to contribute to?
Yes, for sure. We're actually counting on it. This will be, as I mentioned, is the first time we're going to fly P-band, this 435 megahertz frequency. And with this, of course, we're going to basically, for the first time, look at our planet with what I call P-band goggles. So we really are going to unravel completely new things about our planet. And this is always when you fly something new with a new wavelength, you will see completely new things. But we have already identified a few areas for which we know there's a good chance that we can do some real nice new science. One of them is looking at the forest floor. As I already mentioned, that we're going down with a signal, we're able to penetrate down to the entire forest layer, and we're actually also sensitive to information we get from the forest floor. Now, with other systems, we always get to say out at the top of the canopy a bit, but we never can create, let's say, a digital terrain model from the forest floor. And about 30% of the land is covered by forest. So all the DTMs that we have, the terrain models and the elevation models, they have a kind of an unknown area. They are not able to precise accurately what actually topography is doing there. So this is something that we hope the mission will also be able to contribute to. A second one is we're looking at ice in the Antarctic, the land ice in the Antarctic, and how it is actually moving. So there are other missions that are doing the same thing, but because again of our penetration into the ice, we'll be able to get access to additional volume scattering that hopefully is going to be stable over time to be able to follow this as well. In addition as well to ice structural information. Then another one that's also very exciting is actually that we're able to look at the deserts and look at paleohydrology. So looking at ancient rivers been dried up, and maybe some remains of ancient civilization that were living in deserts at the time they were not deserts. So this will be, and of course, Thomas, this is not everything. There's going to be for sure, as I said, looking with P-band at the planet, we're going to be in for some surprises there.
Wow, I mean, really, really exciting stuff. And yeah, I think we can all be very, very excited about the science surprises. I would say, though, as an operations person here in this room, we don't like surprises. We hope everything goes according to plan. So far, indeed, everything is good. You can see on the board behind me that we're all green. ESOC is very much ready to take control of the spacecraft when it separates not long from now from the upper stage of that Vega C launcher. But for now, I would like to say thank you very much to our launcher for giving us a gentle ride. We will continue enjoying it here in the control room, and we will be back to talk to you later once we've separated to catch that all-important moment of first acquisition of signal. Thank you very much. Back to Katie.
Thank you so much, Thomas and Bjorn. So great to hear from you both and have such a fantastic description of this terribly, terribly important satellite. Okay, so we're going to take a break now because we're coasting without the engine. So we're going to cut our mics for 20 minutes. We're coming back at 7:05 Kourou time. That's 11:05 here in UCT, Universal Time, 12:05 in Paris. And if anyone wants to ask a question,
put them in the chat.
Yeah, put them in the chat box on YouTube or any of the social media. I think you'll do your best to answer later. Okay, see you in 20 minutes. Bye.
Goodbye.
À tous dans le CDC. Donc on approche de l'acquisition non Norcia. Merci de baisser un peu le volume.
Hello again and welcome back to our YouTube Live. We're coming to you from the European Spaceport in South America. We are 51 minutes into the launch of Biomass for the European Space Agency, and those images were the launch, which took place 51 minutes ago. We lifted off from the pad here at the spaceport, and right now Biomass, our very precious satellite, is hurtling through space, attached to what's left of the upper stage. I'm Katie Haswell, and joining me in the commentary box is Samuel Rogers. Samuel, great to have you with us. Thank you.
Thank you. Great to be back.
Yeah, Samuel is a real rocket science expert. We're very lucky to have him in the commentary box. Samuel, just run through what's happened for anyone who missed the beginning.
So we had the first phases of the flight were first the ignition
Acquisition de la télémesure par la station Norcia en Australie.
He's just letting us know that we've picked up the signal at the new Norcia tracking station in Australia, so we're checking in with the teams there.
So we had main steps were first stage burning,
Le
so
pilotage est calme
320.
de l'étage avant.
Then we had the second stage, Zefiro 40, for a bit more than 2 minutes, then the Zefiro 9 for 2 minutes and a half, and then the first boost of the Avon Plus upper stage over Canada, and we had a long pause over the North Pole without propulsion, and then we have just had contact with the New Norcia ground tracking station, and we'll be ready soon to fire the Avon Plus again for the second time.
You can see on the left-hand side those events, what's coming up and what's already happened, what's happened in blue, what's coming up in white, and our telemetry on the right-hand side of the screen. We've got some hot news from the Guyana Space Centre. The team's tested a new solid propellant rocket motor called the P160. That was a few days ago.
Yes, indeed, and it's a major milestone.
Début de la manœuvre d'orientation pour le deuxième boost à Vom.
I will interrupt while he is speaking. It's a major milestone because it's a key development for future
Fin de la
upgrades
manœuvre d'orientation.
of both Ariane 6 and Vega, Europe's launchers. This new motor is 1 meter
Pression
longer
réservoir nominale.
than the P120, and it carries 14 tons additional propellant.
And we've got here the switching
Allumage confirmé de la
on of the upper stage, which has now been confirmed. And here's the picture. We can actually see the hot fire test there of the P160
Propulsion nominale, pilotage
firing
calme.
up.
And it's really key because it will increase the Ariane 6 and Vega performance, their payload capacity and their competitiveness. So really a very good complementary development for these.
Trajectoire du lanceur nominale.
He's telling us that the trajectory is normal, everything's going according to plan up there in space. We've had a question from somebody called X who is asking Samuel, why does the fourth stage burn for so long? Is it in orbit yet?
So yeah, we are in orbit, but not at the right altitude. So we are, in fact, we are like in a roller coaster. So first we have picked up some speed thanks to the solid
Décart en
boosters.
altitude, pression chambre nominale, trajectoire nominale.
Thanks to the solid boosters and the first Avon burn, then for the first 16 minutes of the mission, and then at the end of this first boost we were at the bottom of the roller coaster, starting moving up, and during the break we have slowly lost speed, but we moved up to higher altitudes, and in physical terms it means we have transformed the kinetic energy, meaning the speed, in potential energy, meaning altitude. So now we are close to reach the top of the roller coaster at
Il n'y a pas d'écart en
670
altitude, la trajectoire est nominale.
at 670 kilometer altitude. So it's the right time to fire again the upper stage. So in other words, we were in an elliptical orbit, and we're waiting to get to the apogee. This is the highest altitude point, to burn again the upper stage and circularize the orbit. This is the technical term for it.
So it's a bit like we were at the top of the roller coaster, and instead of coming back down, we just keep on flying.
Exactly, flat.
Slightly terrifying concept.
Extinction de la Vom.
We've had the confirmation there that we've switched off the Avon Plus upper stage, so that's good news. Another very important moment. So as you say, we're
Orbite
on
atteinte par la Vom
altitude.
correcte.
And this is a precise, very important information. The orbit
Début de la manœuvre d'orientation au profit de Biomass.
we have just reached is the right one. So now we're performing quite a set of maneuvers to orient the satellite plus what remains from the launcher to point the satellite into the right direction, the one required by the customer for biomass separation.
Alright, welcome back everyone to the launch coverage here of the Vega C rocket launch with Biomass. We are a few moments or quite a bit away until the separation of the payload. Everything has been going normal at this point. So yeah, let's return to their commentating.
From the mothership. That's coming up in less than 30 seconds now. Very precise orientation maneuvers up there in space. These computer-generated images showing us exactly what's been planned for today's mission.
Fin de la manœuvre d'orientation.
So we have reached the end of the maneuver.
So we're getting ready now to separate biomass.
Séparation biomasse.
Nice.
Merci d'attendre.
Confirmation there that we have separated the Biomass satellite. This is wonderful news.
Great news.
Congratulations to all the teams, everybody involved.
Nous
This has
attendons
been,
la confirmation de l'acquisition du signal du satellite.
he says we are now waiting for the confirmation of the acquisition of the signal of the satellite. That is, of course, when the satellite will talk to us.
Say this, yeah, hello to
And
them.
say hello. It'll call home to the teams at the European Space Operations Centre who have now taken on their new baby. And we're hoping to hear now from the CEO of Ariane Space, again, David Cavallolis, who spoke with us earlier. And look at those wonderful images there, the computer-generated images, the CGI animation of biomass. It looks like it's floating away, but it's actually travelling incredibly fast still, isn't it? It was 28,000 kilometres a
It's
second.
fast with respect to the ground, but it's slow with respect to the launcher. We want the separation to be gentle, not to have too high speeds to avoid any risk of collision. So it seems to be slow, but it's really fast with respect to the ground.
Teams here in the Mission Control Centre, everyone very, very delighted now that we've had the separation. So let's go over now to David Cavallolis, who joins us once again from the fishbowl. David, thanks ever so much for coming to talk to us. So good news.
All right, that's gonna conclude the coverage here for me. The payload has successfully separated from the launcher here, and that will conclude the coverage here. I might be extremely blind. I believe it has separated. It has successfully separated from the capsule here, so that will conclude the coverage here. Yeah, hold up a minute. So yeah, a successful launch just occurred an hour or so ago. A successful launch, and successful separation of the stages, and now a successful payload separation where the customer needs to be. So that concludes a successful mission for Ariane Space and the European Space Agency. So next up will be the launch of the Firefly rocket, or the Firefly Alpha's rocket, with a Firefly and message in a booster. So we will be back then. Until then, have a nice day, everyone. So yeah, we'll see you then.